Welcome to this tutorial. This tutorial is called A Gentle Introduction to R. In this tutorial, I'll show you some basic functions of R, some basic capabilities of R, and how you can explore R. This is by no means a comprehensive introduction to R, but it'll give you somewhat of a highlight reel of some of the things that you can expect to work with when working in this environment. So have your RStudio program open. It should look something like this, where we see immediately we have our console here, and notice down here that we have our cursor. And so you can type commands directly into the command line here in your console. And so this is one thing that we can do as part of R or RStudio. So for instance, you can use R as a basic calculator if you'd like. So let's type in 3 plus 2 and then hit the enter button on our keyboards. Down here in the console, you'll see that we get the response or the answer, the output of 5. Now, note with R, it doesn't matter whether or not you have spaces or don't have spaces between these different operations. So for instance, you could do 3 space plus 2 plus space and then 2. So 3 plus space, and then you have another space after the plus sign and then 2. And if you hit the enter button again or the enter key on your keyboard, you again will see that you get 5. Okay? Now, as you can see that we can use the plus symbol that you're probably familiar with. If you want to do 3 minus 2, you would simply do 3, the minus sign, and 2, and you get 1. If you would like to do 2 times 3, for instance, you actually use the asterisk symbol here. And so if we hit enter there, you get 6. And what about 2 divided by 3? Well, you do 2 and then / and 3, and you get the output there of approximately 2/3 or 0.66 repeating. Now, what about an exponent? Well, an exponent, let's say you want to do 3 to the second power or 3 squared. You would do 3, and then you do the upward caret here, and then the power here, which is the 2. So if we hit enter, we get our response down there, which is 9 in our console. Now, what about a square root? Well, actually with a square root, we'll use a function. And so it's simply sqrt, and then we do parentheses. And within our parentheses, we simply put the number that we'd like to calculate the square root. So let's do 9. And hit enter, and you get the response or the output of 3. So at its most basic, R is just a basic calculator, and you can decide how you'd like to format, whether you want spaces before and after the plus sign or the asterisk or what have you. It's completely up to you. Now, one thing that you'll note here is that I'm typing this directly into the console, and what this doesn't allow for is for me to actually save this work that I've been doing easily or to easily annotate it. So typically we like to work within an R script editor, or what I often refer to as an R script file. So how do we get there? We go to File, New File, R script. You select that here, and you'll see a new window pane open here. And so here we can type in the same type of calculations that we were doing below in the console. So let's say that we type in 3 plus 2. And up here in our script, instead of if you hit enter here, you'll see it just takes you to the next line as though you were in a word processor or something like that. If you'd like to run this, you can either put your cursor next to the line or highlight the whole chunk here or the line, either way. And once you do that, you can click the run button. Or if you hover over here, you'll see that you could also do a control enter. So I could do a control enter here because I am working from a PC. If you were working from a Mac, I believe the equivalent is command enter. So you'd have to hover this over in your Mac version of RStudio to see how that works. Okay, so this is one of the nice things about working in a script editor is we can actually save our work here. If we put it down here in the console, watch what happens if we do an edit and clear a console, which is Control plus L if you'd like to use the hotkeys, but let's just click on this. We lose everything down here, okay? So instead we can create a paper trail here, and this will become much more important when you do more advanced things within R and you work on entire projects within the R environment, both managing, analyzing, and visualizing data. So another benefit of working from a script editor like this is that we can actually annotate things. When I say annotate, I mean write notes to ourselves and to others who might interact with this program. And so in R, if you'd like to annotate something, use the hashtag symbol. or the pound sign. And anything that comes to the right of that hashtag on that particular line is going to be an annotation. And basically this just tells R, don't run anything that appears after this pound sign or hashtag symbol here, because it's not actually a function or anything that needs to be run. Rather, it's an annotation. So let's say that I want to make a note to myself what I'm doing here. Demonstrate addition in R. Let's say R as a calculator. Okay. And so watch what happens. If we highlight these two lines together and click run here, you'll see that it ignores this first line here. So it's not going to give you an error message or anything like that. And it still computes the line that does not have this hashtag in front of it. Now you can also use the hashtag to the right of a function or to some type of equation or something that you've put into your script editor. And so I could say 3 plus 5 here. And watch what happens when I run just this line and I highlight that annotation here. It still only gives me 5 and there's no error message here. Now watch what happens though if I put this here without a hashtag in front of it. So 3 plus 5, and I just run this selection here by highlighting and clicking run. We get an error message down here in our console that says unexpected symbol in 3 plus. It doesn't know what this means. This doesn't correspond to any function, and it's not written in a way that's understandable to R. Okay, so I encourage you to annotate as much as possible because this tells the story of what you're doing and why you're doing certain things within the R environment. So from here on out, I will just show you how to work in your R script editor here, or in other words, your R script file. And this creates a .r file that will be saved to wherever your working directory is. And so we won't talk about working directories in this gentle introduction to R, but there is a separate tutorial that covers what a working directory is. But if you'd like to save your R script file, you simply go to Save As. And I'm going to save this as test here. It'll override an existing one. Save. Yes. Okay. And so you can actually save your R script in that way. Okay. So the next thing, and you'll see here, a little bit delayed there, but here we have the name of the file appears here. And so anytime you make a change, this turns red. And that means that you need to save it if you need to update it. Save frequently is my advice. Okay, so now let's talk about functions in R. So we got a little taste of that a little bit earlier when we used the square root, the sqrt function here, and we used it to calculate the square root of 9. So if we highlight this chunk here, we see that we get in our output down here 3. Okay? Now watch, we can also do this too. We can highlight everything we've done so far and run through it, and it does everything in the order in which it appears. Okay, so order of operations is really important in R. But another really common function and that you'll come across is what's called the print function. But what does the word function even mean in the context of programming or R specifically? When we're talking about a function, we're talking about an integrated set of instructions that is going to be applied consistently. Okay, and within each function, we might also apply different arguments. And an argument is essentially something that's going to refine the set of instructions that is part of that function. Okay, and so that's the basic language that we use when we're talking about functions. We have the function, and then within the parentheses is going to be some kind of argument that we enter in there. Okay, so another common function is what's called the print function from base R. When I use the term base R, I'm referring to a function that comes standard from R. So when you download R and then now we have RStudio sitting on top of it, we can readily access these common functions. Okay? So the print function, and this is important, R is case and space sensitive, is all lowercase print. And then type the parentheses symbol. Okay? And then you need to put something as an argument into these parentheses. So the function is called print, all lowercase. And then within the parentheses, we're going to put some type of argument. So let's say that we want to put something like data science is cool, exclamation point. Well, we can come here and we could either highlight this or just leave our cursor there and click run. And what this is doing is saying, print this down to our console. So here we see as our output, it's not terribly exciting, but we get data science is cool. So the argument here within the function is what we put in the parentheses here, and it's data science is cool. Now notice we use double quotation marks around this, and the reason that we do that is simply to indicate that this is one chunk of text that is essentially all tied together. It's one unit, in other words. Okay? Now, we can use double quotation marks like this. We could also use single quotation marks, or what you might think of as apostrophes. So we could do, let's delete this, put one here, and it works just the same way if we run it. Okay? And you'll see down here in our output, it even puts the double quotation marks back in there. Okay? So this is an example of a function here that's pretty common. And again, this is one that's standard in base R. But watch what happens if we capitalize something in a function name that shouldn't be capitalized. So here I've done a capital P, and I'm going to do data science is cool. Same thing as before. And let's just run that. Could not find the function print. So this makes a huge difference to R here. It doesn't recognize this function unless it's specified and written exactly as it should be. Now, let's say that you want help about, okay, what is this function? What can it do? Well, it's actually really simple to do that in R. So let's say that one way to do it is to just put a quotation, or rather a question mark, in front of the exact name of a function. You don't need to put the parentheses after it. You just want the function name here. And so let's, keeping our cursor there, run that line here. And what you should notice is in your help pane over here that you'll see a basic description of what this print function is. And it says specifically print values is its purpose. You see the arguments. So these are the different arguments you might add in here. And then usually there's some reference material, and often they'll have some types of examples. And these examples will vary in terms of their helpfulness. It really depends on who wrote this particular section. And so some are really helpful and some are going to be a little bit less than helpful in terms of the types of annotations they provide or the examples they provide. And so another function that you could use to actually assess or to get help is to use the help function. And within the help function, as your argument, put the name of a function. So it sounds a little weird, but watch what happens here. Does the same thing. So it's the same effect as just putting the question mark. I recommend just using the question mark directly in front of the name of the function. And again, we could come down here to our console if we wanted. If we really didn't want to track this, for instance, in our script, because it's not really that relevant, we could just come down here and do question mark print. And we'd get the same thing. And notice right here it says base. This is saying this function is from base R here. Okay? All right, so now let's move into another concept that's really important within R, and that is the package. So anything that comes with standard with R or from base R, you don't need a particular package to use. So a package is essentially a collection of functions that some users have created, and it's very carefully vetted when new packages and associated functions are introduced. It's a quite rigorous vetting process that occurs to actually get a package listed on the official R website, the comprehensive R archive network website. So a package is just simply something that is a collection of functions, usually related functions. So for instance, you might use the psych package, which is all lowercase p, s, y, c, h, and that function has a lot of functions. That package has a lot of functions that are associated with things that you might need when you're doing assessment of data that comes from human beings. So in other words, psychometric data or data that we would collect in a psychological context, or even more generally, a social science context. So that's one package that we might use. And within that package, we'll have different functions that we can use. For instance, the psych package has a function called alpha, and that calculates Cronbach's alpha as an estimate of internal consistency reliability. Let's now look specifically at a package, though, that's called lessR. And lessR is a nice introductory package for those of you who have very little exposure to R or no exposure to R, because it kind of crams a lot of things into each function that are going to be, that otherwise will require extra steps to generate this extra information. And so some of this extra information that's automatically generated with these functions by default within the lessR package includes things like data visualizations, diagnostics, assumption testing, and so forth when it comes to statistical analysis. And so the less R package, which is developed by David Gerbing, a faculty member at Portland State University in the School of Business, looks like this. It's less R, so less is lowercase and R is capitalized. And so if we want to access a package, we need to use a function called install packages. So here you can see as I start to type this in, RStudio is already recommending something for me. And so install packages is the name of the function. And then we need to enter quotation marks and within the parentheses. And as our sole argument, we're going to put less R. So this is the exact name of the package here that we're going to install. Okay. And so let's run that. And you'll see here a stop sign appears as you start downloading and updating everything. And here, once everything stops and the stop sign goes away, you'll see that something that looks like these things are all successfully unpacked, these packages that on which LSR is based. So that's another thing. Often functions have dependencies, meaning they're not just built from scratch, they're built on other existing functions. Generally, the idea is to make things to add functionality or to make things more user-friendly. With less R, it's to do both, add functionality and make things more user-friendly. So this installs our package to whatever location you see here. We'll see the downloaded, this is the path extension here. So it's going to install it, but the next issue is that we need to actually check out this package. So you can think of a package as being this library of functions. And so how do we check out a book, or in other words, a function from that package, or in other words, access that package? Well, we need to use a different function then called library function. And this is library all lowercase. And so let's type in less R here. Note that we don't put the quotation marks around here. So the sole argument within the library function here is going to be less R. And if we hit run, you'll see now we get this loading here. And so here we get some red text. This isn't actually bad. We do get a warning message just saying that this was built on a more current version of R than what is currently downloaded on this computer. But this is just some general information, contact information if you have feedback, and associated website and so forth. So you don't need to install a package every time if you already have it on your computer, although I do recommend doing this fairly regularly because a lot of times these packages do get updated frequently. And so there might be some additional functionality and stuff that might be beneficial to you if you keep them up to speed. But you will need to, anytime you open a new session and you want to use the functions that reside within this package, you need to make sure that you access them using the library function here. Okay. All right, so the next thing that I'd like to show you what you can do with R, and let's make sure we save this here by clicking on the little disk button there, or you could go up to File and Save if you'd like, or Control S if you're using a Windows version of RStudio. But now let's move into what's called variable assignment. And so what I mean by variable assignment is that we're going to assign a value or set of values to a particular object. And so when you hear object in R, this is anything that we can work with. So R is an object-based language. And so we're going to be working with objects within R, and sometimes our objects will serve as our arguments within our function. So this hopefully will become a little bit clearer in just a moment here. So let's say that just if we were doing like basic algebra or something like that, that we have a variable that we're going to call x. Well, how can we assign a value to that variable? Well, we can either do this symbol right here, the less than symbol followed by a dash, and this looks like an arrow, so it's pointing to the left here. And we could assign 3. So this would say that x is actually equal to the value 3. And if we run that line here, you'll see that we don't get an error message down there. And let's now print, use that print function, and as our sole argument, we'll put that new variable we just actually defined here or assigned the value to. So print, and within this is x, and it needs to be, again, this is case sensitive. This is a lowercase x here. This needs to be a lowercase x specified here. We can click run there, and we'll see that when we print this, x is equal to 3. Now, fun fact, you don't actually need to use the print function. You could just type in x here, highlight it, or put your cursor next to it, click run, you get the same output here. Okay, so by default, it will just print this if you put your cursor next to it. Now, we can use that arrow notation that I've used here, or you could also, some people prefer to use the equal sign. So let's now override that existing value. So anytime after we've done something, we change the value or just use the exact same value, it overrides the existing value. So let's do x equals to 2. Click run. And now let's print x again. And you'll see that x has been updated to 2. Now watch what happens though if we use a capital X here instead of a lowercase. Object not found. This is the object that we assigned, which is serving as our variable. Really, it's more of a constant in this case, but it's called variable assignment. And this was lowercase, this is uppercase, so we get an error message here, okay? We can also assign characters, so non-numeric data to a particular variable. So we could do y, and I prefer to use the arrow symbol here. We could do y is hello world, not hell world, hello world. And let's click run. And then watch what happens if we do print y here, and that's a lowercase y. We get hello world down here, okay? So that actually brings me to the next topic, which is types of data or types of variables. And this is important. So I just mentioned non-numeric or numeric and character data and so forth. And in R, there are actually going to be several or multiple different types of data. So we have numeric data, and actually a specific type of numeric is integer. And then we also have character data. And we have date data. And we have logical data. Okay? And so this up here, anything you put in quotation marks is going to be an example of character data. Okay, this tells R that this is character data. Okay, and so we can actually use different functions to determine whether or not something is, what type of data or variable it actually is. So let's say, for instance, we can use, really you get to about the same point, we can use what's called the class function from base R or the str function, which stands for structure. So I'll show you the class function. It's all lowercase here. You don't need a specific package for this because this comes standard with base R. And let's do x. So this is what we assigned up here. Remember, our most recent value is x is equal to 2 in terms of the variable assignment. And we click run. Let's look down here. We get numeric. Okay. Now, let's say that we want to change x to an integer. Okay, so from numeric to a specific type of numeric data called an integer, which means that there's no decimal points or values after the decimal. Okay, if we want to do that, we actually need to use a little bit different notation. So let's do x is going to 2 is going to be assigned to x, but we need to put a capital L here. An L next to a number indicates that it's an integer. So let's click run. And now let's run class again on x. And we get integer, okay? So, and this might not seem like a big difference, but this can actually trip up functions later on. Some functions are very particular, whether they want numeric or integer data, okay? So this is important to consider here. All right, so what about character data? Well, we already saw that up here. So let's say class for y. So we already programmed or assigned hello world to y here. So let's do class y, and let's run that. And we get character. It tells us it's of type character. And what about date? Okay, so date can be a little bit trickier here. And the reason that I say that is that dates can be, I find that they're one of the more tricky types to actually work with. So watch what happens here. Let's say we have another variable we wish to assign, and anytime you use a date, you would put them in quotation marks. So let's say 2019, and let's say January 1st, or rather January 5th, okay? So this is the typical default date format that we would use in R here, okay? All right, so let's go ahead and run this. And watch what happens though. Watch what happens if we do class and W here for that new variable we just assigned. You'll see that it's character, it's not a date. So here comes another function. Let's say we want to change W to a date, to a variable of type date. Well, this is where we actually need to take W and say, okay, we're going to override the existing W, and we're going to apply a function from base R that's called asDate. Okay? And in this, we're going to put W, because remember we assigned W here as being this, which R recognizes a character initially. Okay? So watch what happens here. So we're going to override the existing W variable with a new W that is of type date using this as.date function here. Okay? Now watch what happens when we do class and W. We get a date, and notice that R capitalized the D in date. Okay, so that's one thing. The character is all lowercase, integer is lowercase, numerics lowercase, but the D in date is going to be capitalized. Okay, so the last type that I want to show you in terms of variable type or data type is what's called a logical. And so logical, just think true or false or T or F, capital T, capital F. Okay. So let's say that we have another variable Z and we're going to assign true to it. So you don't, with logical values, you don't need to actually put these in quotation marks even though they're text. And so Z is, we're assigning Z to be true. Click run. And let's see what type of class that is. Class of Z. Let's click run. And we get logical. Now we could also use, as I mentioned earlier, the structure function, which is str. And we put Z as the argument in that function. And here we get a little bit more information. We get logi, which stands for logical and true. And you could apply this Z function or the str function to X as well if you wanted, or to the other one. So we get integer and then the value 2. Okay. The SGR function can actually be applied to something we call a data frame too, which is when you essentially have a whole data set read into R as a complete object. It's like a big table essentially. And you can find out exactly what all the different variables in your data set, what the different variable types or data types are. Okay, so the last things I want to talk about is the difference between a vector and a list. Let's do vector versus list here in R. And so when you hear vector, this is actually just a sequence of some types of consistent data, okay? So they all need to be of the same type. So they all need to be numeric, or they all need to be integer, or they all need to be character, they all need to be dates, okay? You can think of vectors as being kind of a variable is a good example of a vector. So variables are going to have the same type of values typically, okay? And so how do we actually assign values to a vector? Well, let's say that for a new variable, so we've already assigned X, Y, Z, and W, but let's say that we have a new variable that, well, actually, let's call this one V for vector. And we're going to assign, instead of a single value, when we're doing variable assignment, we're going to assign multiple values to it. And so we'll use a function that is the C function, which stands for combine. So C, it's lowercase. And let's say that we want to create a vector of numbers that's 1, 2, 3, 4, and 5. Okay? And if we run this line here, and then we do print V, we get a vector listed out here of 1, 2, 3, 4, 5. Now we could also do, let's say, U. And for U, and actually you don't need to have a space between these if you don't want. Like I could do this, but I like to keep the spaces for legibility here. Everybody develops their own style. Okay, so let's say that we want to create a value of string or character data. And so let's say yes, no, yes, and let's finish this up with no. Okay, so notice here, because I'm doing character data, I need to actually put I need to put commas in between. Well, we use commas above here, but I need to put quotation marks around the values because we're doing character here. Notice too that anytime we have a comma within a function parentheses, so again, C is the function and these are all our arguments here, okay? So this is the first argument, and we use commas to separate arguments within functions, okay? So it's the same thing down here, except this is character data. So let's assign this vector to the variable u. And now let's print u. And we see down here in our console, we get the output, which is that vector we created. Now, what happens if you want to create something that is actually doesn't have consistent types, or has different types rather, of variables or data within it? Well, this is when you create what's called a list. So we use the C function to create vectors, and we use the list function to create lists, okay? So let's assign a new variable, and let's call this one t. And this one we're going to use to create a list. And we'll actually use the list function from base R, which is all lowercase, list. And in this, let's do first an integer. Let's then do character data. Let's do true. So this is logical. And let's then finish it up with a numeric value of 99. Okay? So watch what happens when we do this. We can highlight this and assign this list to t, the variable here. And let's use print and t as our sole argument, and that's a lowercase t. And here you will see that we have our list down here, okay? So this is the list of different values, and notice they're not of the same type down here, okay? So that's just the difference between a list and a vector here. So this has been a very gentle introduction to R. Be sure you save up here. And so as this gentle introduction to R, again, this is by no means comprehensive, but hopefully this gives you some insight into some of the basic foundations of what it means to work in R. When I use the word R, I'm using it to also refer to the fact that I'm working in RStudio, which sits on top of R. RStudio tends to be quite a bit more user-friendly. It's easier to format things within R, and there's a number of other functions that are beyond, and capabilities that are beyond the scope of this initial tutorial that RStudio has, that makes it very, very easy to use, and quite robust, and makes it easier to manage projects and stuff that you're working on. Okay? All right, so again, we've saved our work here in the script editor, the R script file. And once you're done with a session, you can go up to File and go down to Quit, or you could do a Control Q if you are working within R, or if you're working within the Windows format. Or if you check out this function that's just simply lowercase q, and we use the question mark here to run this and see, you can also terminate your R session if you were to use Q or type out the function quit. And you could just do Q without any argument within it. Alternatively, quit works as well. It's the same thing. Sometimes you have functions that have brief versions of the names. Okay? All right, so if we scroll up here, we can see everything is here that we've done. If you wanted to, you could come and you could run the entire selection here, and it'll run through everything. Here it's asking me if I want to update any loaded packages. I'm going to hit cancel there because I don't really want to do that at this point in the tutorial. But as you can see, it ran through everything that we had in our console here. Okay? All right. Well, this is a basic, brief introduction to RStudio and R. And hopefully it was gentle enough and that gives you some insights in where to go as you move forward.